We're solving 21 from the Fall AMC 12A from 2021. Let ABCD be an isosceles trapezoid with BC parallel to AD and AB equals to CD. Points X and Y lie on diagonal AC with X between A and Y as shown in the figure. Suppose angle AXD equals angle BYC, which is 90 degrees. AX equals 3, XY is 1, and YC is 2. What is the area of ABCD? You know that that's a right angle, and therefore that is a right angle. Now, we know that AB is CD. Oh, and this is solution 1 of this problem. This is useful. Will be useful later. But for now, well, the whole area of this figure is going to be, well, this is very strange area to compute as we don't know this height. What we can do here is, well, if we turn this a bit clockwise, so much so that the length AD is parallel to the ground, we see it is a trapezoid, an isosceles trapezoid, and the area for one of those is simply 1/2 times the two diagonals. We already know the lengths of one of the diagonals, AC. This is simply 2 plus 1 plus 3, which is 6. And the equation states that you have to multiply by 1/2 times the second diagonal. This crosses out to be 3. So our area is 3 times diagonal 2. Now we can set up a sort of equations for similar triangles as we realize that CYB is similar to AXC. So therefore, we know that CY over XA, we have these two lengths, so that's 2/3. Therefore, we can assign variables to these where XD, or I should do BY, where BY is equal to 2 times a constant, say S, and where XD is 3 times a constant S. So we can just write it on the board. There. So we have those values. Well, if these two triangles are similar, we also are given, or we know that length AB is equal to the length of CD. And since these are both right triangles, AYB and DXC, we can use Pythagoras' theorem to find the hypotenuse and set them equal to each other to find the value of S. So for this one, the base is going to be 3 plus 1, which is 4, squared, plus 2s squared. So this is 4s squared plus 4 squared. And this is the length for AB. Now for DC. 2 plus 1 is 3, so that's going to be 3 squared plus 3s squared plus, this is just 9. So we know that this is 4s squared plus 16 is 9s squared plus 9. These can cancel to get 7. And 7 is going to be equal to 5s squared. Therefore, s is going to be irrational, which is the square roots of 7 over 5. And that's a little less than 1. So now that we have that, we can simply utilize this information to find the lengths of this big diagonal here. So this is whole area is gonna be 1/2 times 2 times 7, square root of 7/5 times 6. Then you have to add the other diagonal thing, or 1/2 times 3 times 7/5 square root times 6, which is gonna be equal to 15 root 7 over root 5. Now, what you can do here is, since the answer doesn't have an irrational on the bottom of the fraction, you simply multiply both sides by square root of 5 over square root of 5 to get our answer of 3 root 35 for this first solution of our problem.